Today we will learn about abrasive jet machining. This process is differ from sandblasting in that abrasive jet machining has smaller diameter abrasive and a more finely controlled delivery system. And workpiece material is removed by mechanical abrasion of the high velocity abrasive particle. So first of all, gas supply that will pass through a pipe and nitrogen, CO2 or air. These are generally used gas in abrasive jet machining, and the velocity of this gas supply generally varies from 150 to 300 meter per second, and flow rate is generally maintained 28 liter per minute. And this is the filtration of the gas supply here with the help of a filter. And on the further step, here is the pressure gauge, and the pressure of the gas is maintained between 2 to 8 kg per centimeter square. And after that it passes through this is the mixing chamber, and in this mixing chamber the gas supplied is will be done with the help of a regulator. So from regulator this gas comes into the mixing chamber, and this mixing chamber here is the abrasive. It is silicon carbide or aluminum oxide. Generally the size of the abrasive is 25 micrometer and flow rate 3 to 20 gram per minute. And aluminum and silicon carbide powder are used for heavy cleaning, cutting and deburring. And sometimes magnesium carbonate is recommended for use in light cleaning and etching, and sodium bicarbonate is used for fine cleaning and cutting of soft material. And the commercial grade powders are not suitable because their size are not well defined, and they may contain silica dust which can be a health hazard. And it is not practical to reuse the abrasive powder because the contamination and worn grit will cause a decline of the machining rate. So this is the vibratory source. Because vibration is generally provided up to 50 Hz, the abrasive powder feed rate is controlled by the amplitude of the vibration in the mixing chamber. And from this mixing chamber, this is the nozzle through which the abrasive plus gas supply is passed through this nozzle, and the material of the nozzle is tungsten carbide, and generally the approximate diameter for the nozzle that is 0.3 to 0.5 mm, and the speed that is 150 to 300 meter per second. And this is the workpiece on which machining should be done. And from this nozzle, this is the jet that is coming out from the nozzle, because the jet that strikes with the workpiece, basically with the help of jet intricate and precise shape can be produced by using mask with corresponding contours. So as we can see here, vibration of the mixing chamber starts, and jets is coming out continuously from the nozzle, and that hammered the workpiece. Typically the abrasive particles from the nozzle follow the parallel path for a short distance, and then abrasive jet that flashes outward like a narrow cone when sharp edged abrasive particle of aluminum oxide or silicon carbide hit a brittle and fragile material. As we can see here, mixing chamber is vibrating, and these are the abrasive particles that is hit the surface of the workpiece to get the desired shape, to get the desired hole and slot. And this material removal rate is mainly dependent on the flow rate and size of the abrasive. If we have the larger grain size here, then it produces the greater removal rates. So now the advantages of abrasive jet machining: no tool changes are required. Second one, it can machine thin materials, not reactive with workpiece material utilization is high, and it is best suited for the brittle and heat sensitive material like glass, quartz, sphere, and ceramics, etc. Now the limitation of the abrasive jet machining, generally its material removability is slow, silica dust may be a health hazard, and soft material cannot be machined, stray cutting cannot be avoided. And here are some application of this process. The first one is it is generally used for frosting the glasses, delicate cleaning of irregular surfaces, removal of film, micro deburring of hypodermic needles, and machining intricate shape, and deburring cross hole, slot, and threading in small precision parts, for example aircraft fuel system and hydraulic valves, wire cleaning without affecting the conductor. So this is whole the process that we have learned abrasive jet machining. If you have any question, any queries, then you can ask by commenting. Subscribe to get more updates. ENGINEERING 22, you may like, share or comment and give your suggestions if required. Thank you. Have a nice day.